Hey folks, in this lecture we're going to learn how to securely transfer files between Linux systems using SCP and Rsync over SSH. These tools are widely used in production environments and are also part of the RHCSA exam objectives. You may be asked to copy a file from one system to another, sync directories, or even verify that the files were transferred successfully. This skill is extremely useful in real-world administration, whether you're taking backups, deploying files, or collecting logs from a remote server. Now, before we begin, let me clarify one important point. These tools work over SSH, so SSH must be enabled and running on the target machine. Also, while these tools can be used from Linux to Windows with extra setup, in this lecture, we're focusing on Linux to Linux transfers, which is what's tested in RHCSA. To begin the demo, I first check if my target machine is accessible. I type the command SSH client1 at IP address 192.168.81.130. This means I'm trying to connect to a machine where the username is client1 and the IP is 192.168.81.130. When prompted, I type client1 password and the connection is established. The system also shows a fingerprint the first time and asks me to confirm by typing yes. This is normal when SSH is connecting to a host for the first time. Once I'm in, I type who am I, and the output shows client1. That confirms I'm logged into the correct user on the remote system. Then I type exit to return to my original system.
Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Now let's start our first file transfer. I want to send a file called file.txt from my current system to the home directory of client1. So I type scp file.txt, client1 at 192.168.81.130:home/client1/. This command means take file.txt from this system and send it over SSH to the remote system, placing it inside the home directory of client1. After typing the command, I'm prompted for client1 password again. Once entered, the file transfers successfully and I get a progress bar confirming that file.txt is 100% transferred. Now I want to do the reverse pull a file from the remote system to my current machine. So I type scp client1 at 192.168.81.130:home/client1/file.txt space dot. This time the source is the remote system and the destination is the current directory on my local machine represented by a single dot. Again, after entering the password for client1, the file transfers successfully. Next, let's transfer a folder. I have a folder named my folder that I want to send to the remote system. So I type scp-r myfolder/client1 at 192.168.81.130:home/client1/. The -r flag is required to copy directories recursively after entering the password, the folder, and its contents. In my case, files like a .txt and sample.txt transfer successfully to the target system. Now let's move on to Rsync. This is a more advanced tool used for syncing files and directories efficiently. To send a single file using Rsync, I type rsync-avzfile.txt client1 at 192.168.81.130:home/client1/. The hyphen. A flag means archive, preserving permissions and timestamps. The V flag is for verbose and Z enables compression during transfer. After entering the password, rsync confirms that file.txt was sent successfully, along with transfer stats. Now I want to sync an entire directory. So I type rsync-avz my folder /client1 at 192.168.81.130 /home/client1 /my folder /. This command syncs the my folder directory and its contents to the target machine. Again, after typing the password, rsync lists each file as it transfers and confirms the directory is synced completely. Now let's reverse the direction. I want to copy the same folder from the remote machine back to my local system under a new name. So I type rsync-avz client1 at 192.168.81.130 /home/client1 /my folder /space dot /my folder underscore copy /. This command copies the contents of my folder from the remote system into a new directory called my folder underscore copy on the local system. After typing the password, the transfer completes, and I can see the folder now exists locally. Now let's try transferring a large file with some additional options. I type rsync-avz-progress- partial large file.iso client1 at 192.168.81.130 /home/client1 /. Here, hyphen progress shows live transfer progress, and partial allows resuming a partially transferred file if the transfer gets interrupted. After entering the password, rsync starts the transfer, and I see a detailed progress report. Next, I want to verify if the file that was sent is exactly the same on both systems. On my current machine, I type md5sum file.txt. The output shows a checksum hash for file.txt. Now I want to check the same hash on the remote system. I type SSH client1 at 192.168.81.130 in quotes md5sum /home/client1 /file.txt. After entering the password, the command runs remotely and returns the exact same hash. This confirms that the file wasn't corrupted during transfer. Finally, I SSH into the remote system one last time to visually verify that all transferred files and folders actually exist. I type SSH client1 at 192.168.81.130 and enter the password. Once logged in, I type ls/home/client1. The output shows all the files, file.txt, large file.iso, and my folder confirming that all our transfers succeeded. I type exit to disconnect from the remote machine. Back on my original machine, I type ls/home/Oliver, and I see file.txt, large file.iso, and my folder underscore copy, confirming that the received files are also present locally. And with that, we've completed this hands-on lecture on transferring files securely using SCP and Rsync. We've seen how to copy files and directories in both directions, preserve metadata, resume large transfers, and verify file integrity. These tools are tested in RHCSA and heavily used in production. If you're still unclear about anything, try practicing different combinations like copying to a different folder, renaming during transfer, or syncing with exclusion options. And remember, practice makes perfect, especially when it comes to file transfers across Linux systems. Keep practicing, and I'll see you in the next one. And let's keep learning together.